Okay, well, it's not totally obvious what to do. This is where a graph would be very helpful. The key is T on the second graph might not be the same as T on the first graph. Okay. Only got about 3 minutes to be able to kind of sketch this. But let's say your parabola on the first graph is not as steep as your parabola on the second graph, right? So here's your parabola on the first graph. I'm kind of mixing up the first and the second graph. It's the one, it's not 10 centimeters per second squared. And this would be a parabola. Okay. The second parabola I'm getting first and second mixed up. I didn't have time to eat anything between classes. So my brain is about to run out of oxygen and everything else. Let's see. I think I phrased this wrong. The first graph is the one where the ball moves more slowly. I apologize. Gotta do something about this. Mainly, I gotta eat something between classes, and people need to talk to me. No excuse. Okay. I'm gonna have to stop this because I'm not going to give you a clear explanation. I'll just say you're going to have two different parabolas. If you started them at the same time, then the parabolas would look like this. So here's P and here's X. At any point, the distance between the balls would be distance from here to here. At this time, call this T half. And this arrow here represents the separation of T half. Does that make sense? Because at the same time, this ball is going this far, this ball is going this far, so the difference is this. That's how far apart they are. Okay. If you start them at different points, then second ball would start a little bit later, but it would be steeper and the two parabolas would eventually meet. And here would be the parabola for ramp 1. And here would be the parabola for ramp 2. The initial position is no longer 0, right? So your equation would have a non-zero initial position. The balls meet here, but they also have to meet at the end. The equation on ramp 2 would be, I'll call it x2 of t equals f of 33 is about 16. Wait a minute, we got 33. So your x of t would be this times plus 2x0 would be half of that. Actually be about 17 centimeters per second squared and so forth. On ramp 1, you still have your 5 centimeters per second squared times t squared. You can't read that square there. So what you're trying to solve for is this x2 mod. Does that make any sense? Does the picture kind of make sense? If you start it further along, your parabola is going to be shifted to the right. And if this is a steeper parabola, it will eventually meet this parabola. Of course, we want them to meet at the end, which throws another algebraic complication. Okay, that's an example of a pretty challenging problem. And the first assignment in chapter 2 is not due until Monday. The second one's due a couple days later. Okay, you won't see anything like this till you get to the second. What we've talked about so far gives you a good start on the first part of the chapter. Read the text, understand, do the problems, do the demonstrations and all that stuff. And it should pull this stuff together if you're well versed with these equations. Okay, I'm sorry for running out of mental energy. At the end here, again, I'll figure out how to deal with that.